Hi everyone, I'm Sam Sultan from Blanivo. I wanted to share a brief video on how generative AI has evolved over the years. So, generative AI essentially is a branch of artificial intelligence and also a subset of deep learning. So, the focus here is creating models that are capable of generating new contents and perhaps most of these contents are very similar to the existing data. And these models are trying to generate content that is almost identical to the ones created by humans. And these contents could be anything from code and images all the way to 3D objects and videos. It's probably very clear that generative AI is transforming all sorts of industries from healthcare to retail. In healthcare, for example, it's helping doctors identifying the diseases early or even customizing treatments for patients. Or we see in finance where it's catching fraud and predicting market trends. In retail, we see that using it to manage stock or create personalized shopping experiences. And I guess if I want to summarize it, I say Gen AI is a game changer that is making everything smarter and more efficient. Um, I probably quickly touch on the different types of generative AI models. So there are two major type of generative AI models that we call unimodal and multimodal. So the unimodal models is normally taking instructions from the same input type as their output. On the other hand, we have multimodal models that are taking input from different sources and then also generate output in various forms. For a unimodal, I can talk about GPT-3, for example, that is more of a text-based model that generates human-like text, or we have Stargan, that is an image-based model that can create realistic images. And for multimodal, a great example is DALL-E, which essentially generates images from textual description. You might have heard of Clip, which understand images and their descriptions, and it perform tasks that require understanding both visual and textual information. So now that we have a better understanding of generative AI, it's probably worth getting deeper into the history to see how it has evolved over the time. So I probably start with the early foundation. So when we talk about early foundation, we talk about hidden Markov models or HHMs, or Gaussian mixture models or GMM, sorry, that are introduced in the 1950s. So the journey of generative AI started in mid 20th century, where we had probabilistic models like hidden Markov models or Gaussian mixture models, and again HMM introduced in 1950s. That's basically a statistical model that created system with hidden states through observable sequence. Um, these models were basically used in speech recognition and sometimes in bioinformatics. And then at the same time, we had the GMM that created a method to model data distributions using a mixture of multiple Gaussian distribution. And this was for more complex reasoning. And after that, we progressed to n-gram language models. And then there was a time that we had more computational power in hand. So the focus shifted towards modeling language. N-gram language models was relatively simple, it's not very powerful approach to being able to predict the next word in a sequence based on obviously the previous words. By 1980s, these models were becoming the foundation of natural language processing, or NLP, if you like. They were specifically very helpful to handle short sentences, and it's not far from truth if I say they laid the groundwork for other complex language models. And then after that, this was around, I guess, 1990s or early 2000. There was a significant shift when the concept of neural networks was introduced. So first we had recurrent neural network, or RNN, which could handle sequence of data using a memory of previous inputs. Having said that, the traditional RNN that I just mentioned relatively struggle with long-term dependency, which are not the focus of this short video, and we're probably not going to get into the details. But to address this, researchers developed the long short-term memory model, or LSTM, and that was around 1990s. LSTMs had some mechanism to keep information over long periods, which was making them very useful for tasks that required long-term context, such as language translation and time series prediction. Um, and then we had the gated recurrent units that was introduced in early 2000s. And the effort here was more on optimizing the process by simplifying the internal structure of LSTM, and um, and then we see researchers started focusing more on this, and then we had GRUs where it was performing very well while being very computationally more efficient, and perhaps this was the reason behind being utilized more often in AI application. So as you probably see, the evolution from HMM, and GMM to advanced neural networks like LSTM and GIUs, there was a very progressive enhancement in handling temporal and sequential data. And you probably also noticed that each of these innovations were built on the shortcomings of its previous ones. And collectively, all these models were able to push the boundaries of what generative model could achieve. And as I mentioned, these models were laying the foundation for modern generative AI models, including the ones we use now in our AI application. In this very short video, I'll just want to quickly touch on the evolution of generative AI. Thanks for watching. I hope you found this short video informative and learned something new about generative AI. Again, Sam Sultan from Blue Thanks for watching.